Hello everyone. Let me start with the new objective for the today's lab, that is a microphone preamplifier. So as you can see here is a microphone phone preamplifier circuit schematic that we need to design. So the problem statement says that you need to design a single-sided PCB layout using through-hole components. Provide an audio jack at the audio output, and PCB dimension should be 40 by 60 So this is a problem statement. So I need to design a schematic. This is a simple schematic, as you can see. These microphone preamplifiers are always going to be inside a mic. So before we give it to the final stage, okay. So we need to capture the audio signals from the mic, which is of low amplitude. We need to amplify it. There are different stages, some uses op amp based, some will use transistor based amplifier. So this is a simple op amp, a single stage amplifier, which will actually amplify these signals which is taken up picked up by this microphone, and it will be amplified and given to audio output. We could barely hear this. Even if you build this simple circuit using a 9-volt battery, we can also do this. So let me design a schematic for this. So here is a schematic incomplete. So as you can see here, this is a schematic. We have a microphone and few passive components, and resistors, capacitors, and there is an audio output, which I said we need to connect this audio output using a audio jack and a power input. So that's it. Let's begin with the Kicad tool. So I'm going to create a new project here. So project, let me create it in location, yes, here under CAD cam. Let me create another folder for lab 2. This is my lab 2 example. So under lab 2 I'm going to create it. I'm going to name the file as a microphone. So my project name, I'll keep it as microphone. Save it. So this is the schematic file that's going to open. So, and I need to fill some of the settings, page setting information here. So the revision is version 1, and title is microphone preamplifier, and company is ECE. So I'm going to give some details here, so that will appear here. Now let me simply quickly take up all the component. First procedure is to make the view selection. I think grid view selection, you can just choose what grid view. So it is at 10 mils, it's more sufficient. Let me quickly take up the components. The first main component is a mic. Okay, so simply search microphone. So here is a condenser microphone. This is a symbol. So all these are different symbols that are used for a, let me use a simple microphone. There's a condenser microphone. Zoom in, insert it over here. This is a condenser microphone. Next component that I need is actually the IC. You can just have a look here. Yes, here I need some few resistors. Many resistors required. I think 1, 2, 3 and 4 resistors are required. Let me quickly add this resistor. Search here and R resistor, and I'm going to control C, control V, or right click, duplicate, right click, duplicate, right click, duplicate. 4 resistors will be taken up. Then I need another component called op amp, TL0 71. As you can see here, TLO 71. So TLO 71 component is here. Single low noise JFET operation amplifier. So this is the one. So let me add another component, that is a capacitors I need. I think you see 10 microfarad, 1 capacitor, 1 microfarad, 10 microfarad, 2, 1 microfarad, 47 microfarad. All are electrolytic capacitor with the 4 numbers. Okay, so let me add those capacitors quickly. So this is capacitor. So under device capacitors, polarized capacitors I will choose because this is electrolytic type. So I need 4 such capacitors. Right click C, or you can also press the shortcut key C. It will duplicate. Again C, duplicate. So this makes the work very simple. Let's look at, I need one more resistor, I need an audio jack, and I think yeah, 9-volt battery. So I need a battery here. So what I suggest is to select a battery. Battery, single cell battery is more enough. With the two, it's fine. So I need an audio connector, actually audio jack. So let me find it in connectors. So audio jack. See, there are audio jack dual. Uh, it depends. So this is a simple audio jack, as you can see here. So let me take up this as an audio jack. Okay, signal, and the T is actually the serves as a ground. Okay, or else you can also take up a jack, uh, stereo. This is a mono jack. Okay, this is a mono audio jack where I'm going to take out the audio signals out. Now let me quickly rearrange this component. So let me make this microphone somewhere here. Look at the signal. Okay, then I need this 10k m to move it. Quickly move it here. Then I need 1 microfarad. So let me make a movement for this 1 microfarad. Rotate it. Use R somewhere here. Perfect. Then I need another 62k. This is almost proper. Then I need 62k. I will move this as 62k here. Fine. Then I need another 10k. Rotate it R. Move it over here. Look at this 2 and 3. I think we need to flip it. So right click, orientation, x-axis. So this will serve the purpose. Then I need 10 microfarad. Move it over here. That's good. Then I need another 10 microfarad. R, move it. Just look at the symbol, it is plus actually other side. So again rotate R. So here. Okay, and this also connect. Then I need another 10 microfarad over here. 47 microfarad is this. I'll put it over here. And audio jack, I'm going to move it somewhere here. Rotate it and place it. Right click and you can change the orientation of this. Probably X mirror I will do. Signal. Okay, that's it. So I'll move this a bit to this side, and let me move this close. That's it. Okay, so it's complete now. So I'm going to wire this. So if you want to wire it, zoom in and start quickly wiring all these components one by one. Okay, it's done. Connected here. I think we need to connect like this, so but we have to cross over it. Okay, so you can make one crossover, not an issue here. It's understood. Sorry, zoom in, make this correction, zoom out, look at the schematic again. Pin number 2 is supposed to be here. Zoom in, and again this is supposed to be connected here, and we have to connect this as well. Zoom out, and this should be connected capacitor here. Again this one to be connected. Yes, done. So I will connect this T of the audio jack to the ground, because we are going to take the signal with respect to ground, and the signal I'm going to take it from the output of the amplifier. And this capacitor output, the capacitor should be connected to the supply. Zoom out, zoom in, take out this connection from the battery and give it here to this. Fine. Another one, take up, that is a ground here, and this and okay, so here V plus and V minus is written, so V minus is ground, so I'm going to place a symbol here, ground, over here. So G and D, ground, and this is a ground symbol, place it over here. Then C, copy the another one, place it over here. That's your another ground. And let me take up this connection, let me wire it here to this, and this one to 4. Fine. 1 and 5 are for the null, so which are not connecting here, we are keeping it open, and that's it. Okay, we need to give the power to this VCC. So what I suggest is uh, okay, you can actually make a wire label here, say this as VCC, put it over here, connect this to VCC, and same wire label, you can choose it here, click here and choose a wire label as VCC, say OK, click it over here, and that's our VCC. It's perfect. Sorry, it's not done properly. Yes, this is how we create a schematic. My schematic is complete now. So this is how we draw a schematic for the preamplifier circuit. Okay, let me assign a footprint for that, each one of this component. So we quickly assign the values: 10k, 62k, edit 10k, and edit 62k, and this one is 1 microfarad, edit 1 microfarad, if I'm right. Another is 62k, and this one is 10 micro, 10 micro. Another value is also 10k. So edit, this is 10 microfarad, and this will be again CP 10 microfarad, and this is 10k. Fine. And this is 47k, 47 microfarad, sorry, 47 microfarad. I'm done with this connections. So battery value is 9 volts. So if you want again edit here, battery value is 9 volts. That's it. So save this file. Now the next step is annotation. So before assigning the footprint, just annotate the schematic. Annotate. It's done. So the schematic is complete. So if you want to export the schematic to a PDF format, you can just do export to the drawing clipboard. You can copy and you can paste it to a PDF document. And if you have a plotting, you can also do a plotting. Plotting also can be done to different formats. You can see PDF format also I can plot it. You can plot it to the PDF format also. So the next procedure is very important, assigning the footprints. So let me assign the footprint for all these components together. For that I need to do assign footprints. So once you click that, it will load all the associated footprint libraries, and the components will be listed here in the footprint assigning. So okay, now I have this 9-volt battery. Now this time what I will do is I'm going to keep a terminal block for this battery. Okay, I will use a terminal block here. So terminal block is here, and 2 point, this is the better one, 5.08. 2 indicates 2 terminals. Okay, so 2 terminals, 1 microfarad capacitor, choose it under capacitor here, capacitor through hole, and look at the I'll come to the clarification queries later. Through hole capacitors. So okay, this is radial capacitor. Okay, this is called as a radial capacitor. So what you need to do is, if you want to find out say 1 microfarad, typical 1 microfarad capacitors, if you want to find out the let's say 1 capacitor 1 microfarad. So just search it here, and if you wanted to find some information regarding the footprint, you will get some information probably in the images. See, typically footprints values we need to find it in the data sheet. Okay, footprint information. So typically these microfarad capacitors, whatever you see here, it will be around 4 mm, 5 mm. So probably we need to look into the data sheet for that. So if you say electrolytic capacitor data sheet, if you download from the Mouser or some company, you can I'll just log into one of the uh, Mouser Electronics. Just log into this. I'll tell how to search the components in a better way, and valid footprint need to be assigned. So let me get into one of the this wholesale dealer. Mouser Electronics is there, DigiKey is there, Element 14s. These are some of the companies. So what type of the component that you're looking for? You need to type the part number. I say capacitor. I need to find capacitor. So it will all the possible capacitors in its from its database, whether you want SMD. So here you can see here different categories of the capacitors that are listed over here. So okay, so I'm not interested with the ceramic capacitors. So let me type the terminals. Okay, there are different search criteria to choose the capacitors depending on the voltage rating. I can even choose, there are a lot of criteria are there. So aluminium electrolytic capacitor, let me choose. And okay, now this is radial lead I'm looking for. Now let's see the values that I'm interested with 1 microfarad here. That is criteria. Look at this. Look at this. This is the capacitor that I'm using. Look, download the data sheet from here. It will open a data sheet of the capacitors. Now from the data sheet, you need to decide what is the required footprint or the space need to be assigned. So it's about to open. Yes, finally done. So every component in electronics has a data sheet. It could be a resistor, capacitor, anything. There should be a data sheet. Look at this. Look at this. They say there are two leads, L plus which is the longer, L minus is the shorter, which indicates negative. And between these two leads, the gap is written as P. So you need to find out what P refers to from this chart. Okay, so this is nominally is around 5 mm. You can see the nominal is 5 means 5 mm, and there are different code for that. Probably that depends on what type of the tolerance that we are looking for. So let's use one of the series under this. Okay, so let me choose, I'm going to choose a size code as H8. Then I'm refers to this 5 is a mm. So 5 mm is the thickness, sorry, the pitch width. Okay, so I should choose the capacitors radial 5 mm, where the see radial diameter, the entire component diameter also 5 mm, height also 5 mm, pitch is 2 mm. So but I supposed to choose pitch as 5 mm. This is now pitch 5 mm. There are many series that will vary with the diameter of the component and height of the component. Look at the data sheet here and decide what you are looking for. See, height is given as L. This is the L. Length of the capacitor is height. Diameter of the capacitor, so D is around here 10, and L is 16. So what is important for the footprint is these two gap. Okay, so we need to fix it to that. So whatever the value they suggest, if it is, if your height of the device is convenient, you can. So let me use this as the, and 10 microfarad capacitors. So usually 10 microfarad also having the same footprint, so I'm going to use it for the same capacitor. So what I will do is I'll simply copy the footprint, paste it here. 10 microfarad is having same, paste the 47 microfarad may be little larger. Okay, so what I will do is have a look here. This is 1 microfarad capacitors, what they suggest. Okay, and if you look at the, okay, now look at the search criteria here. If you're looking for 47 microfarad capacitors, you need to search 47 microfarad capacitors. So here 47, I'm looking for 47 microfarad capacitors. Apply the filter. So It will update the search now. I get some the capacitors of 47 as well now. Okay, it has appeared. Now you can see some of these capacitors as 47 microfarad capacitors. This is 47 470 volts, 450 volts. This is 25 volts. So if you look at the voltage rating here, they are not given. Probably that is less than this. So I feel you can go for this 45 volt for 70 microfarad. Look at the data sheet once. Different companies, manufacturers, different capacitors with the sizes that varies, and recommended size. You can see the chart here. It says P is the width and D and L and P. Look at this. So P is given as okay, that's a width, and 5D. 5D, okay. 5D is given as 5 mm. This is also given as 0.5 mm is the thickness of the lead, and 6 point, what is it? F is given. See here, F is what? 2 to 2.5 mm. So probably we will use this the D, which is varying for 5, 6.8 and 8. There are three categories available. So I think we can fix it for 3.5 mm as a pitch width here, if you are referring to this. So different component appears with the different size and shape, so you need to choose accordingly which one you are supposed to look for. So let me use the default one here with the 5 mm. That's better for us, which will applicable for this as well. Audio jack, you need to find it in the connector. Okay, connector audio. If you look at this connector audio, so 3.5 mm. These are all SMT, means surface mount. Okay, and this is horizontal audio jack 3.5 mm. View the footprints. So this is actually a stereo. Okay, what we are looking for is a mono channel. So we are looking for a mono channel. I don't know whether it is available here. No, it's not there. So these are all different types of the footprints. Okay. The 3.5. Let me search one more. No. No, this is not the one. No. This is all assembly type, and no. No, this is also not the one which you're looking for. Okay, so I suggest to download a jack for this microphone jack. So I think we'll go with the microphone first. So let me complete this. So microphone, I will use a simple SIL connector. See here under connector you can find FRC. Okay, okay, FFC connectors. See, FRC or FFC connectors, these are all something kind of strip connectors, which you can see here. P is written for the pitch width. So generally the P is written as pitch width. Pitch width means the gap between the two leads. Okay, that refers to the pitch widths. So we are interested with the 2.54 mm pitch width. So probably you can find it here in the some connectors. Okay, you have a connector with here connector header 2.54 mm. This is better. So connector header 2.54 mm. So this connector header I'll use for time being. So I will assign here microphone, this one 1 cross 2. Okay, then 10k resistors. Under resistors you choose through hole, use it. So if you wanted to get some clear gap, uh, what is the resistor footprint? So let me search typical typical resistor footprints. If you search in the image, that would be better. Okay, these are all SMD resistors, and we are looking for a through hole. Okay, I think this may give some idea. Okay, look at this. Okay, this is a better one, I guess. This is a quarter watt, which is 6.3 mm. Okay, 6.3 mm is a quarter watt, and this is zero point 0.5 watt 9. So 6.3 mm they say. Okay, so we will stick to this 6.3. We can choose something, so it depends on from where you are going to purchase all these component and what is the technical information of that. So resistors, through hole, pitch width you need to concentrate. P is for pitch width, diameter and all is for the component size of the component, length is actually length of the component. So we are interested with the pitch width. Okay, and see, resistor can be placed horizontal, vertical. Okay, vertical in the sense they are close, the placement of the component is made vertical in the sense you might have seen a figure over here where a resistor, see, this is actually the vertically placing the component. What you see here is component is placed vertically. Horizontally we place like this. So when you place vertically, the gap will be less. Okay, so that's what the horizontal and vertical meaning here. So we are somewhere with the pitch width 6 point something. So pitch width is 6 point something over here. So wait a minute, resistor through hole, pitch width 10. I think the 7.62 is more enough for me. I'll use 7.62, 7.62, 7.62, 7.62. TL071. TL071. I don't know what that IC is. So what you need to do is quickly download the data sheet of TL071 data sheet. So once you download the data sheet, so in the data sheet you need to find, see here, TL data sheet from the Texas Instruments. Open it in the new tab. So and so let me go through the online data sheet. So in the online data sheet you need to look into the information, especially regarding the packaging. So once you know what is that the data that refers to under packaging, so what you need to see here in data sheet, you have pin diagrams and all that, and finally in the last sheet you get some information regarding the mechanical packaging and ordering and all. Okay, so click on that mechanical packaging and ordering. So you will find some information related to the chip, especially related to the footprint. So under mechanical packaging, I think they are redirecting us to somewhere else. Okay, let me load the data sheet straight away. I'll download the data sheet, that's better. So in the data sheet, you need to find some information here. See, this is a typically how the data sheet look like. First will be, see, carefully look at the information here. Okay, this table device information is very important. So look at this device information which is given here. So there are different series of 7 TL071 X72 X73X. 71X is available with the PDIP SO70 SO SOIC SOT23. This refers to the number 8 refers to the pin numbers, 5 refers to the pin number. This refers to the body dimension of the IC. What is the dimension? So we are going to use PDIP 8 package. Note down this somewhere, PDIP 8 with 9.59 and 6.35 mm. Okay, so if you want to get the detail of this PDIP 8 9 point, so go to the last page of the document. You will find the information related to the dimension of the device. So this is actually, okay, this is the information that I am referring to. See, look at these dimensions. Here pitch to pin gap is 2.54 mm. Okay, this is 2.54 mm. Whereas first pin to the last pin is again 8 times 2.54 mm. Whereas the height of the IC is also given as 5.08 mm. And if you look at the dimension, okay, the one more dimension which you need is the body. Okay, the body of the IC. Look at this, 6.6, and other one is A. A is given here, which is almost for a 8 pins IC. This is not for the 8 pin. We have the dual package. Okay, this is for the 8 pin plastic package, PDIP 8. And if you see here, this is almost 10.16, 6.6 and 2.54 as I said earlier. So we will use the same package on the Kicad. Okay, just come here to the Kicad TL. How do you search package? You look at this package and find out package with the dip, quick package dip. Under package dip, select pdip package dip with the 8. This one, this section 8, and see 8 you have different 16 and underscore W 7.62, all that, this information actually refers to some of the physical dimension of the IC. Okay, 7.62. Look at the data sheet carefully which you have here. So 10.16 I have, which is the length. Width I have 6.6. So Kicad, I have the same. See here, 10.16 I have width. So let me choose this view footprint. So this is the footprint. Now make a roll. So now this indicates this is actually the component, the width. So start from here, measure it here. This is 6.6 and this is somewhere 10 something. Okay, which will exactly matches with our requirement. So this is the one that you are supposed to look for. So use this one. And audio jack, for time being I will use the connector, 2-pin connector on the, I'm not finding because I need to create it. I will tell you how to create a connector. Less for time being, let me use a 2.54 mm ka 2-pin connector, 1 cross 2. I will use this. Okay, that's it. I assigned all the footprints. So So our footprint assignment is complete. So we can save this, and I can just do now Netlist. Before that, if you want to check the design rule, just check the electrical design rule, run it. Probably it may say 4 errors. One is for the powers pin is not driven by the supply, obviously, because I am not given power flag to ground and VCC. Anyway, that's not required. Another one is 4 and 5 are not connected, obviously it is we have purposefully kept it open. That's it. So we do not have to worry about this. We can simply neglect it, because most of the components whichever it need to be connected, they are connected perfectly. So that's about the design electrical rule check. Once you do this, we need to go to the next part, that is actually assigning the creating the layout. So for that we need to do here generate netlist. So just generate netlist here and microphone.net, save it. Okay, so before we generate netlist, let's say we want to order the components on the let's say I want to actually need a bill of material. So I need to send a bill of material to a vendor where I can order this component. For that, what you need to do is you need to create here BOM. BOM is bill of material. BOM is very important, bill of material. You can actually get any different formats here. So we have BOM plugins probably in your so we have BOM to grouped CSV. Okay, use this option and it will actually generate a CSV file in Excel sheet. So you can open it and you can send it for the fabricators. So just generate it. So you can actually find it in the disk here, in the same where I created my folders here. So I have it here in my disk here now. So value added course here, and I have so lab 2 microphone, and you have here an XML and CSV file. Okay, this is actually the bill of material, but I don't have an XML viewer here. Wait a minute, let me take up one more. Okay, just check it here. Nope, it is not created. So actually the bill of materials are necessary for us to purchase the component. We need to get the bill of material. So I will upload a separate video on generating the bill of material, probably in the PDF as well as in the HTML. So we have an option here. One second, let me check it here. Okay, fine, it's generated. Okay, no. Okay, I'll get back to this bill of materials later. So this part is complete. Now what is left is with the layout. Okay, so let me continue with that.